Okay,
Yeah,
so I think we're 1 or 2 minutes past 4 o'clock. So why don't we get a start? See, a number of people have now joined us. So thanks, everyone. Hi, thanks for joining today. So just to do some very brief introductions and housekeeping, if you like. For those that don't know me, I'm Nigel Biswas-Baldwin, co-founder of Fraction. And actually stepping in for Mike Moss today, who's actually studying himself somewhere in the south of France next to the pool. So we've let him off today. So you have the B team with me today, but certainly not in our speaker, Emery. So welcome to the next now webinar series, the big things that are happening in the pharmaceutical industry. And I think, the speakers we've had before and those in the future are very much experts in their fields, and we're delighted to share their experience across the partner network and beyond out into the pharmaceutical community. Just first thing to say really that this webinar is being recorded and may potentially be used for Fraction's promotion and marketing uses. Unfortunately, if you can't agree with that, then I think I have no other option but to ask you to leave the meeting, if you wouldn't mind. But I just want to make that absolutely clear that we will be using potentially for our own marketing purposes. Okay, so really to pass over to Dr. Emery Aymeric. Just to say, I've worked for the last few weeks with Emery and enjoyed the interaction from a scientific and medical perspective. And today he's sharing his thoughts on tackling highly mutating viruses. Will actually artificial intelligence save humanity? And I think, according to Emery, we'll hear from him that it still needs human involvement. But I guess we can question him around that at the end of his presentation. So hope that's good enough billing, Emery, and over to you.
Thank you very much, Nigel, and thanks everyone for dialing in today. So yes, I'd like to talk to you about the three trends in the biotech industry about highly mutating viruses and why AI will hopefully save us, but only when there is actually a human in charge. What we have learned over the last few years is that SARS-CoV-2, the virus that causes COVID-19, isn't the only highly mutating virus. In fact, some of us knew this already. But what SARS-CoV-2 demonstrated was the danger from these viruses to the global economy. What people hadn't really appreciated was what can happen to the vast swathes of the industry coming to a grinding halt when there's a big pandemic across the whole of the economy, from manufacturing to farming to finance, everything coming to a grinding halt, as well as the toll taken on human health. Because as things were going into lockdown, people being unable to work as a result of being unwell or just dead. The number of people dying, number of people chronically ill and short-term ill, this was a huge, huge toll on economy as well as human health. So that's what COVID-19 for the first time demonstrated to us as humanity. Because previously, although we knew about viruses being able to mutate very, very rapidly from things like influenza and also HIV, people didn't really take much notice of that. And we now recognize that there are lots and lots and lots of other viruses and virus families which also mutate very rapidly, and they could cause pandemics now or later on in history or in the future. These are quite a danger. And in fact, whilst we were still within the throes of COVID-19, we had mini scares with Zika and monkeypox. These caused fleeting issues. There were mini scares around the globe in Europe about, oh my God, is there going to be another pandemic? Are we going to have more lockdowns with monkeypox? What's going to happen? And we went back into this thought of more lockdowns, more economic damage, more panic about the effect of highly mutating viruses. And so it made people think a lot. And the future issues aren't actually from some of these, but about the viruses we haven't experienced before. And these are things like Nipah and Hendra viruses, which are much more dangerous than even Zika and monkeypox. These are viruses that are currently endemic in certain areas of the world. They don't tend to travel out very much because they're restricted to populations which tend not to travel much. These are currently sort of endemic in third world countries where the population is too poor to travel out, so the infections haven't really reached the Western population. And the reason why we had such an explosion of COVID-19, and to a certain extent Zika and Mpox, was because they happened in populations either to or from there was travel. And that's what actually causes a pandemic. It's infections traveling. If people don't travel, infections don't get passed around. And currently, the dangerous viruses don't travel very well. So Nipah and Hendra viruses aren't currently an issue because they're not in locations from which there's a huge amount of travel. But if they spread to an area where there was a lot of travel, they would actually be very, very dangerous. So we still need to think about what could happen in the future. And one thing that everybody had really forgotten about, because obviously we all thought that since the Iron Curtain came down in sort of late 80s, early 90s, and we'd all forgotten about the sort of big divide in the world between the East and the West. We thought big wars were forgotten, and we didn't really need to worry about another big world war or even a war in Europe. Turns out that actually maybe we were a little bit hasteful in our thinking. And since February 2022, I think we've all been rather surprised and shocked at what's been happening. And unfortunately, our fears are sort of coming to the fore in that we ignored what happened with various things that have happened on our own shores, in fact, with polonium and Novichok. And we knew that various Eastern states, and in particular Russia, had kept their biological weapons programs going. Didn't really do much about it. But now there is a huge concern that they still have programs active and we have nothing that can actually repel a biological attack. So there are suddenly concerns about potential pandemics and potential warfare with biological agents that we know nothing about. So how are we going to fight against these, and how are the three trends going to be important? Well, there are actually three trends in one in all of this. And a bit like the viruses, artificial intelligence is spreading just like a virus itself. So its use is spreading in surveillance and preparedness for pandemics and epidemics. There's obviously a huge interest in using AI-based symptoms in diagnosis and management of patients. And this isn't just in viral disorders, but in literally everything to do with clinical management. So this is in all disorders, all diseases, from cancer to infections. And of course, there is a huge amount of effort and money being spent on using artificial intelligence to design drugs, particularly antiviral drugs, to increase the specificity of the drugs that we're designing, and also to reduce the development time of the drugs. You know, typically, we spend a huge amount of time and energy to find a new drug, to develop a new drug, and to increase how well our drugs work. Well, if we can use AI to increase the specificity of our drugs, and to reduce the development time, we can save not only on time, but hugely on the cost. So AI is increasing its presence in all aspects of drug development, but in all aspects of healthcare, really, rather than just drug development. So these are going to be really, really key over the next 10 to 20 years, if not further afield than that. So how is AI affecting pandemic and epidemic surveillance? Well, actually, for that, we need to go back nearly 30 odd years, because the first few systems for epidemic and pandemic surveillance go back to mid-90s. ProMed Mail and HealthMap started back in mid-90s. Unfortunately, they didn't really get much of a traction. They didn't get that much funding. And EpiWatch started back in 2016 in Australia, and it didn't get that much funding either. And they were largely sort of localized systems to keep healthcare professionals communicating with each other, for them to exchange data with each other, and for people to just keep each other informed. Following the COVID-19 pandemic, people have suddenly realized the power of information exchange and automating information exchange and data analysis of the information that is being exchanged. And EpiWatch, in amongst all these three systems, is actually the most useful one, because that's the one that's been developed most recently. And that's the one that is actually the most powerful, because that relies on data that's being generated and exchanged between healthcare professionals. And the retrospective analysis of what EpiWatch can do found that it could have detected the 2013-2014 Ebola outbreak in Africa months before WHO was actually notified in March 2014, at a stage of when only about 300 to 400 people had been affected. Now, by March 2014, when WHO was notified, 28,000 people had already died. And by the end of the epidemic, 50,000 people had died. So even by 2014, EpiWatch could have saved more than 50,000 lives. And when that same analysis was done with COVID, EpiWatch could have predicted and could have notified WHO more than a month before it was officially reported. Now, obviously, 2013, 2014 was before EpiWatch was even invented. And COVID-19 happened long before it was properly funded. So now we're looking at what this system can do in the future. And this is what we can now do with today's technology. And these are going to be really, really important, because obviously as the human population increases exponentially, our sort of vulnerability to infections and the spread of infections is going to multiply as well. You know, what makes infections spread more easily is travel and overcrowding and the larger populations in smaller spaces. We now have many multiples of the human population that we had 60 years ago on planet Earth. So it's a simple matter of fact that we are going to have more infections, and we are going to see more epidemics and more pandemics over the next 50 to 100 years. So systems like EpiWatch are going to be really, really useful in not only detecting and warning healthcare providers, but also the pharmaceutical companies in terms of ramping up production of vaccines, ramping up production of antiviral drugs, healthcare providers, doctors, and population, general population, to be aware and to modify their behavior in terms of isolation and social distancing and everything else that we've been doing over the last couple of years with COVID and everything else. So these are going to be really, really important in terms of watching out for pandemic, modifying behavior, and being prepared for it. Just having a bunch of drugs in storage is not going to be enough. We need to know and watch out actively for infections and pandemics emerging. And the really important thing, as I said, is that these tools are now being properly funded and developed by WHO and NIH in the United States. Because without proper funding, none of these tools would actually be useful. So, as I said, ProMed Mail started in 1994, but without proper funding. And EpiWatch started in 2016, but was restricted to Australia. Now it's being funded by WHO, which is fantastic because it means that we can keep an eye on global infection trends. And that will be really, really key. Next thing is using AI for diagnosis and clinical management. And this is a slightly mixed bag because this isn't just for infections, but it does have implications for infections, particularly when it comes to highly mutating viruses. Because computer-aided diagnosis has been an aim for decades. It's been an absolute utopia for both payers and for patients, because for payers, it means that they don't have to pay for expensive doctors and nurses. For patients, it means they don't have to go and see anybody. They can just plug their symptoms into a computer and it gives them the result and answer. And AI tools cover everything from history, symptoms, examination finding, and test results. But of course, to be able to make full use of AI in diagnosis and management, you do actually need to have a trained professional at the other end. You need to put in the accurate information. You need to have a look at the examination. You need to do the examination properly. And you need to do the appropriate tests. You can't put in and do all the tests under the sun. In terms of even taking a history, you've got to be able to differentiate between different types of pain and different precise localities of pain. When you're examining somebody, you need to know what you're examining, how you're examining it, and what the sounds and the feelings actually mean. You can't examine somebody unless you know what the internal anatomy is, and what you're feeling for and what you're listening for is. So you still do need somebody who's actually a trained professional on the one end. And when you look at the accuracy of AI tools for professionals and for the lay public, the AI tools for use by professionals is actually really, really accurate, and in good hands, it's a fantastic, useful tool. And they cover diagnosis, disease progress monitoring, response to treatment, and early detection. And this is where use for viral disorders and viral infections comes in, because one of the things that we obviously noted in the pandemic was that there are a significant number of people who do not have severe symptoms with COVID, but they still are carriers, either at an early stage of disease who are shedding virus, or who never show symptoms but are shedding virus, so transmitting disease. So for those, a system, an AI-assisted system for diagnosis and management for early detection would actually be really, really helpful. So there are now companies who are looking at early detection of viral infections in mildly symptomatic patients. And in fact, if we can combine these with AI surveillance for pandemics, that will be a really, really powerful tool for prevention of pandemics in the future. So as well as looking at and developing AI diagnosis and clinical management tools for general cancers and everything else, it's really, really important to keep a focus on early detection tools for simple infections, because those are the things that are going to have a significant utility when we have a situation similar to what we had with COVID. Those will be the ones that will be able to say, this group of people are the ones that we need to concentrate on, because those are the ones that are going to be shedding virus without symptoms, or with this group of symptoms. So combining early diagnosis tools and clinical management tools with pandemic surveillance tools will actually be important. So these two groups are going to be very important in managing our future. And as I said, these tools do perform much better in the hands of professionals than in the hands of the untrained public. You've got to be able to give a decent history. You know, you learn that at medical school in terms of teasing out what's relevant and what's irrelevant. So that's sort of quite an important point. And I'm not going to go into the ethical questions about data retention, use, and privacy. That would take a massive minefield to negotiate, and bigger than the whole of Ukraine itself. So I'm not going to go into that in here. And finally, the last bit that AI is becoming very, very important in is, of course, in antiviral drug design. From big pharmaceutical companies to small biotechs and startups, absolutely everybody is interested in using artificial intelligence to design new drugs in all stages of drug development. And even NIH in the United States has awarded $68 million to Postera for a project where they'll be working on preclinical machine learning for development of antiviral drugs. And you can use artificial intelligence in drug development in pretty much every area of drug development. You can use it to physically design the drugs. You can use it to model your drug-target interaction. You can use it to model your mutations, drug efficacy, infection spread. You can combine all of those models, and you can use AI in pretty much every aspect of your clinical trial design and result simulation. And in fact, all these tools are currently being used in drug and vaccine development by AstraZeneca, Pfizer, Exantia, and a number of other companies, including my own. And without AI, drug development is actually becoming rather too slow. We are getting to a point where we need to respond to new and emerging viruses very, very quickly. So AI is making sure that we can respond to new and emerging virus quickly enough that we can respond timely. Otherwise, as a virus changes and mutates, we simply won't be able to keep up. And to be able to do that, you actually need to have somebody in charge, because AI is a fantastic tool to assist in designing your drug. Because although AI can actually come up with a drug design, you still need someone to put in the chemical parameters. You still need to have somebody who's giving it the design targets, giving it the parameters for its interactions and the mutations. So you still need humans who are actually in charge of the AI, but it's a brilliant tool in assisting how to design your next generation drugs. And where we can make it more specific is when you're using it in specific technologies. For example, in RNA-based drugs, it's phenomenally useful. And it makes everything much, much, much quicker. So as my final point, AI-based technologies are becoming much more prevalent in every area of healthcare, and particularly with regards to viruses and in highly mutating viruses. They're becoming very important in surveillance for pandemics and epidemics. They're very important for disease diagnosis in terms of early detection and disease monitoring, and they're becoming more and more and more important in designing drugs and new drugs, and in fact, improving old designs as well. But they all need trained human operators for them to work at their optimum level of function. We can't just rely on AI and relax. We do need humans in charge. So that's my final say on the matter, and thank you very much for listening.
Thank you, Emery, and an applause for sure. So I guess open the floor to questions. Please feel free to come onto video, I should have said at the beginning, and ask your question, or there is a chat box, whoever you prefer, or I'll have to pick on someone like Bruce to open us up. So, any questions on the floor there? How about you then, Bruce? Any thoughts there?
Well, I'll always ask a question. Not always an intelligent question, but hopefully something to provoke a bit of discussion. I mean, when I look at, I'm not an expert on any of this, so that's my get out of jail free card. When I look at AI, my biggest worry with AI is if it starts taking over people's jobs, what on earth do we do with the people, or what do the people do? Really, I guess. Question. Okay, so your last slide's a nice one to end on. That's reassuring. 10 years from now, Emery, what would you predict we'll be doing, and I choose my words carefully, we'll be doing with AI in the drug development space?
Well, for me, what I see AI is a better systems tool, to be perfectly honest. I do not see it replacing human activities. I don't see it replacing the lab bench research. I don't see it replacing the intelligent thought processes that go on inside the professor's head. I certainly don't see it replacing the thought processes going on in my head. What I see it using it is making my job easier. Because as I'm working on our own AI systems program, it does what I was already doing, but with less fatigue, less errors, and more quickly. But it doesn't do anything I couldn't do in an infinite amount of time, with infinite amounts of caffeine. It just does it much quicker with sort of a lower error rate, and fewer nights sort of burnt without candles. So it's a massive assistance tool, but I do not see it replacing actual human beings in terms of physical work that needs to be done. It can only do so much. It can't replicate real life, and it can't generate theories. I don't see it generating new scientific theories. That simply, I think, is beyond the point that we are at. It might get to the capability of generating new scientific theories, but I haven't seen the evidence of that yet.
So I guess the conclusion would be that we won't need less people. We'll have the same number of people, but we'll basically be able to do much more.
Absolutely. That's my perspective, and that's my thought on it.
Very good. I see Lisa. Hi, Lisa. How are you doing? You're kind of our in-house AI expert as well, as Emery.
Oh, no, I was fascinated to hear what you had to say, Emery, especially because it really links to what my thoughts have been around AI. I actually have a question for you, because I believe that you do some work in the clinical trial space as well, don't you?
Yeah.
What do you see as the advantages of using AI, just to improve, to facilitate, to speed up clinical trials? Because they're eating massive amounts of money and massive amounts of time. Is there any way that we can use AI to get drugs to market faster?
I think there are two things about AI. One is people using AI because it's the thing to do. So anything that has AI attached to its name is just attracting a huge amount of money, even though it's a complete waste of time. So there is a huge amount of money being wasted just because someone says, this is AI, this is brilliant, and this is the way to do it. And I think there is actually a huge amount of time and money being wasted just because somebody is calling something AI and it looks good and it looks shiny and polished and everyone thinks it's brilliant. So I have this awful fear that there's a huge amount of polishing going on for something that's actually absolutely rubbish, and doesn't actually help with anything. And where I see AI helping is really, as I said before, helping us do things that we would otherwise be able to do, or we wouldn't otherwise be able to see without a huge amount of work, automating things and seeing patterns where we wouldn't be able to see otherwise, analyzing data in real time as it comes through clinical trials. So doing that kind of stuff is brilliant for AI to be able to do. You know, you can't have a researcher up all night analyzing data as it comes through from a clinical trial, but you can have an AI system that's capable of doing that 24/7, that's constantly live, that's taking in all data as it comes along, analyzes that and continuously reports on that, and that can give you signals all the time for safety. So you can have that kind of AI systems going on for an active clinical trial. So there's lots that AI can do to make clinical trials safer and quicker. But I think there's a huge amount of money that's also being wasted because people are calling stuff AI just because it looks good.
I think you and I are on the same page. I think AI is useful for pulling out the unusual, the ones that, the pattern recognition.
Yes.
And, you know, just automating that so that people don't have to focus on that all the time. It can be done by a machine and people can focus on what do we do in order to follow up on those unusual patterns or the, you know, the outliers. So I'm with you. Yeah. Thank you. Thank you for that. Very interesting.
Thanks, Lisa. Are there any other questions we have from anyone? So put your hand up. There's the chat box as well, if you're a little bit shy. I usually am, so. Good questions there. So I guess then just, Emily and Lisa, I'm just going to be slightly controversial, though, around the requirement for a human and around clinical trials and clinical development. I guess just during my 25 plus years, where I've seen inefficiency is in human decision making and bad decision making, led by, you know, office politics, your particular fashion, all those sorts of things that have actually led to, you know, maybe good drugs being, you know, going in the wrong direction or not move forward, all those things. So, you know, I think maybe there's a trade-off here between the computer sort of breaking through some of that stuff and actually making better decisions in your drug development. I guess you'd agree with that, Emily and Lisa?
Oh, absolutely. I mean, you can model precisely what your drug is going to be able to do with its chemical targets. You know, you can see that much better when you can move things around in 3 dimensions and you can see the interactions that your drug will have with its target, or it just simply won't, the ones that you predict. It's much easier that way. And you can just design your drugs in a way that will work. So that's what AI allows you to do. You can design your drug in the way it will work very, very specifically and very, very precisely. So in terms of drug design, by the time you've finished designing your drug, you know it's going to work. Or when you're testing the drug, you know, in a chemical simulation model, you can see if it's going to work or not going to work. And, you know, there's no point in taking it any further than that. If it's not going to work, that's it. It's pointless. You don't need to waste money spending kind of millions taking it through a clinical trial. It's not going to work. Why bother?
Well, I think, Emery, we should all come and work. Maybe we will come and work with your biotech, with the
Oh,
AI
yes.
technology you have, and the drug will work, and that be often a unique experience for many.
Well, it's easier with certain sort of drug technologies than others. You know, this isn't obviously as easy with every drug, with every type of drug in every disease area. So certain disease areas and certain types of drugs, this is much easier to implement. So it's not going to be useful for everything. But when you pick and choose your area, when you concentrate on your specific area, it will work better. So I know how to apply it in my disease area and what I'm trying to do. And if people apply it to their own areas, they can make it work in their areas. So just because I've made it work and I know how to make it work, I won't be able to work it in somebody else's area without a huge amount of work on my part. But there's no reason why they can't apply it in their area as well. So, you know, take what we've done and just use it in your area. It's, you know, yes, it will take time, but it's worth the effort. Definitely worth it.
Good advice, Emery. So, okay, just a little bit conscious of time. If there are any final questions, please shout now. Otherwise, we'll come to the close. Okay. Gone, I guess. But okay, so thanks everyone, particularly Emery, for a fascinating presentation and discussion. I think again a great example of sort of sharing the great experience we have across the partner group and teams.